Okay, so the first question is 2 times 3 plus 7 plus 2 squared plus 3, parentheses 6 minus 2. What is this equal to? So pause the video and try to solve this now. Okay, let's go over how to do this one. So the key to getting this right is to know your order of operations. So the order of operations rules tell you the order that you have to do the operations in, meaning your addition, subtraction, multiplication, division. And so you always want to do the parentheses first, start with what's inside those parentheses, then go to your exponents, then multiplication, then division, and then after you've done your multiplication and division, you can do your addition and subtraction. Now, technically you can do subtraction before addition. That's not really that important to remember to do addition before subtraction, but the important thing is that you want to do make sure your multiplication and division are done before you go on to addition and subtraction. So just follow the rules here and you'll be okay. So to follow the rules here, we want to start with what's in the parentheses. So we want to focus on the 6 minus 2 here first. And so 6 minus 2 is just 4. All right, and so the 6 minus 2, we can just rewrite that as 4. Okay, and so then we've handled our parentheses. So next we want to look at our exponents. And so here we have 2 squared. So 2 squared, we want to handle that exponent next. So 2 squared is equal to 2 times 2. All right, so 2 squared is equal to 2 times 2, which is equal to 4. So this 2 squared, we can rewrite that as 4. All right, so let me cross this out. So now let me rewrite this whole question here. So we still have 2 times 3. So we have 2 times 3 plus 7. Now we have plus 4 plus 3. And then we have in our parentheses our 4 here. Okay? And so this parenthesis here, when you have 3 parenthesis 4, that just means 3 times 4. Okay, so now we want to do our multiplication. So we see 2 multiplication cases here. We see 2 times 3 and we see this 3 times 4. So 2 times 3 is 6. So we now have our 6. And we have 6 plus 7 plus 4. And what about this 3 times 4? So 3 times 4 is 12. So we now have 4 plus 12. So we've now reduced this down to an addition question here. And so let me clear this 2 squared out here. And so hopefully you got that in your notes if you wanted to put it down in your notes. So I'm going to clear this all out of the road here. And if you want to get those notes, you can just pause the video and rewind it at your leisure to make sure that you've gotten this. So now we just do our addition here going from left to right. So 6 plus 7 is 13. And 13 plus 4 is 17. And so we now have 17 plus 12. And so you can, of course, always plug this into your calculator, but we can also do this without our calculator. So the way that you would do it without your calculator is you just line it up. So we've got 17 plus 12, and 7 plus 2 is 9. 1 plus 1 is 2. And so this gives us 29. So 17 plus 12 is 29. So this whole entire question, the answer ends up just being 29. So the answer to 17 plus 12 is 29. So that's question number 1. 29 is our answer. Clarify something here. I know I said that you do the parentheses first in your order of operations rule. So you do the parentheses first, except when you have something like this, like 3 parentheses 4, because this 3 parentheses 4, that's technically just 3 times 4. Question 2. If f of x equals x squared minus 12, what is f of 4? Pause the video and try to solve this now. Okay, let's go over how to do this. So this question involves functions. So what is a function? Well, a function relates an input to an output. So when we see this notation f of x, you can just think of that as function of x. So this f here, this is what we call the name of the function. So this f is just the name of the function. So it could be a different letter, it could be g. So if this f was a g, then the function would be called g of x. Or if it was an h, we would call it h of x. Okay, and so this x in here, this is what we call the input. So remember, I said that a function relates an input to an output. All right, so function of x means that here your x is your input here. All right, and so this whole part of the question here, this x squared minus 12, this tells us what the output is going to be. All right, so this is our output here. And so basically, you're going to put something into the function and you're going to get an output. So it's like if you go to a vending machine, you put money in, that's your input, and you get something out, which would be a drink or a snack or whatever it is. All right, but that's kind of the idea of a function here. You're putting in an input and you're getting out an output here. So when it says what is f of 4, f of 4, in this case here, remember what goes inside of the function here, what goes inside of these little parentheses is our input. So 4 is our input. So all we're going to do to solve this question is we just plug 4 in for x here. So what do I mean by that? Well, what I mean is that everywhere in our equation here where we have an x, we're going to replace it with a 4 here. So we have x squared minus 12. So that x squared, we're just going to take that x and we're going to replace it with a 4. So when I say plug 4 in to the function here, all I mean is you're just taking this 4 and you're just replacing the x with a 4. So you're substituting 4 in for x here. So we have 4 squared minus 12. So f of 4 is equal to 4 squared minus 12. Hopefully you see the connection here, right? Because f of x is equal to x squared minus 12. So if we have f of 4 is just 4 squared minus 12. Now if it was f of 5, it would be 5 squared minus 12. Or if we put in f of 10, it would be 10 squared minus 12. So in this particular question, it's 4. So we plug in 4. So our input is 4. So we have 4 squared minus 12. Now 4 squared is equal to 4 times 4. All right, so 4 squared is 4 times 4. Okay, and so in any question with an exponent, you've got your base and you've got your exponent, or you could call it a power here. All right, and so this number up here, the exponent tells you how many times 4 is going to appear in a multiplication here. So we have 2 here, so we have 4 times 4. So the 4 appears in the multiplication 2 times. Now on the other hand, say if it was 4 cubed, all right, that would tell us that 4 is going to appear in multiplication 3 times. So we would have 4 times 4 times 4. That would be 4 cubed. All right, so just a quick little lesson on powers or exponents. All right, and so we've got 4 squared here. So 4 squared is equal to 16, right? Because 4 times 4 is 16. So some people call them power rules, some call them exponent rules. All right, but the idea here is that 4 squared is 4 times 4, which is 16. So we now have 16 minus 12. 16 minus 12 is 4. All right, and so the answer is 4. So f of 4 is just equal to 4 here. So that is your answer. Okay, this next question has to do with adding fractions. So we have 5 over 9 plus 3. What is this equal to? Try to solve this, and then we'll go over how to do it. Pause the video and go ahead, try it now. All right, let's go over how to do this question. So there's a lot of lessons to learn here. And so one is that whenever you see a number, like a whole number, like 3 or 5 or 6, whatever it is, you can always think of that number as 3 over 1, or whatever it happens to be. 5 becomes 5 over 1, or 6, you can think of that as 6 over 1. Okay, and so now we're adding 2 fractions. We have 5 over 9 plus 3 over 1 here. Okay, so the idea whenever you want to add fractions is you have to get a common denominator. So to add fractions or to subtract them, you have to have a common denominator first. So the top number in any fraction is what we call the numerator. So I'm just going to abbreviate numerator with n. And the bottom number in any fraction is what we call the denominator. So in order to add these numbers up, we have to have the same denominator here. Okay, so what we're going to do is we want to look at 3 and we want to look at 1 here, and we want to think, well, how could I make this 1 become a 9? And we do that by multiplying it by 9. And so the idea, though, is that when you have this fraction 3 over 1, you've got to multiply both the top and the bottom number by the same thing here. All right, so we've got 5 plus 3 over 1. Well, we've got to multiply both the bottom number and the top number by 9 here. All right, and so what do we get when we do this? Well, we can rewrite all of this as 5 over 9 plus 27 over 9, right? And it's now 27 over 9 because we just did 3 times 9 and 1 times 9. All right, so whenever you have a question like this and you have the same denominators, you can write it as 2 different fractions like we have here, 5 over 9 plus 27 over 9. Or if the denominators are the same, which they are, you can just write 1, 9 down here, and you can just write it like this. You can just write it like 5 plus 27 over 9, okay? And so to solve this question out, we want to do 27 plus 5, okay, which is going to be 32. And so we now have 32 over 9, and that's the answer here. So this type of fraction is called an improper fraction. So whenever you have a fraction where the top number is bigger than the bottom number, or in other words, where the numerator is bigger than the denominator, we call that an improper fraction. Now, if it had been the other way around, if it had been like this, if it had been 9 divided by 32, this would be what we call a proper fraction. So in a proper fraction, the top number, or what we call the numerator, is smaller than the denominator. So in this case, our answer 32 over 9 is an improper fraction, and we can convert an improper fraction to a mixed number. So there's another type of fraction called a mixed number, and so just know that we can take an improper fraction and convert it to a mixed number. And if you're not sure what I'm talking about here, you can check out my video on fractions, which I'll link to down below, and you'll learn how to do that there. But the answer that I'm looking for here is 32 over 9. You could also turn this into a decimal. If you did 32 divided by 9 in your calculator, you would get a decimal answer. And so let me check that out here. So we would do, the answer to that would be 32 divided by 9. And if you did it that way, yeah, you would have 3.555. That would be the decimal. So if that's the answer that you got, then that is also correct. Okay, question number 4. The number A is 30% of B, which is 30% of C, which is 30% of D, whose value is 50. What is the value of A? So pause the video and try to figure this out. Okay, so let's go over this. So it's easy to read a question like this and kind of come away from it with your head spinning. So if that happens to you on your test, you just want to take a deep breath, read the question again a little bit more slowly the second time, and just look at it and break it down piece by piece here. So we're trying to find the value of A here, okay? So this question involves a lot of percent. So what a percent is, it's just a number that's divided by 100. So in other words, a percent is just a fraction and it's over 100. So percent means per 100 here. So for example, we have 30%, okay? 30% is just a fraction, all right? Where we have 30 divided by 100, okay? And so any fraction, right, so whenever we have a number divided by 100, we don't even need to, we can just write it with this little percent symbol, right? So when we have 30 divided by 100, we don't even need to call it 30 divided by 100, right? We can just call it 30%. So it's the same with any number really. So what about, for example, 5%? How could I write 5% as a fraction? Well, to write 5% as a fraction, I would just say, well, percent, that means per 100, so that's 5 over 100 here, all right? Or let's say, for example, we've got like 67%, all right? So if I said what's 67% equal to as a fraction, we know that the percent tells us, hey, 67% per 100. So we would write that as 67, all right, over 100. Okay, and so we can also write these as decimals. So 30 over 100 is equal to 0.3. Okay, now 5%, or 5 divided by 100, that's equal to 0.05. And 67 divided by 100, or 67%, that would be 0.67. All right, and so you can get these numbers by using your calculator. You could do 30 divided by 100 in your calculator and you'll get the decimal. You can also use the percent button on your calculator, but the most important thing is to start seeing this pattern here, right? So for example, let me give you one more, and this is really important to understand. So 4% as a fraction would be 4 over 100, but as a decimal, it would be 0.04. All right, so hopefully you're starting to see this pattern here, whereas 40%, all right, so 40% as a decimal, it wouldn't be 0.04, it's just 0.4, okay? So hopefully you're starting to see that pattern there. And so this is important to understand. Every step of this, every concept here is important to know for your test, not just how to get the solution, all right? We want to understand not just the solution, but we want to understand every concept that's involved in this question so you can get questions like this right in the future here. So, but the main thing to focus on here is we have 30%, and that's equal to 30 over 100, or 0.3 here. So we can now start writing some equations here. So we see that the number A is 30%. So we can say that A is equal to 30%, or 0.3 of B. All right, so A is equal to 0.3 times B. All right, so 30% of b, you would just do 30% times b, or 0.3 times b, or 30 over 100 times b. That's how you would get that. So if we knew what b was, so say b was like 70 or something, we could say 30% of 70. The way that you would get that is you do 0.3 times 70. All right, so in this case, we don't know what b is. So we know that a is equal to 0.3 times b. All right, and so it says, which is 30% of c. So b is 30% of c. In other words, b is equal to 0.3 times c, which is 30% of d. So that part of the question, which is 30% of d, tells us that c is equal to 30% of d. So c is equal to 0.3 times d. And we do know what d is, right? So it says whose value is 50. So that means d is equal to 50. So now all we're going to do is we're going to work backwards because we know what d is, okay? So let me put a box around this. So if we know what d is, we can find c because c is equal to 0.3 times d. So the way that we find c is we do c, all right, is equal to 0.3 times d, which d is equal to 50. So now if you run this in your calculator, you'll get 15. So c is equal to 15. So now that we know what c is, we can get b. And the reason is because b is equal to 0.3 times c. So to get b, we have b is equal to 0.3 times what? Well, times c, which we know is 15. So again, you'll just run that in your calculator, and you'll see that the answer is 4.5. So now that we have b, we can get a, because a is equal to 0.3b. So a is just equal to 0.3 times b. And what is b? Well, we just found that b is equal to 4.5. So we just run that through the calculator. So do 0.3 times 4.5 in your calculator, and the answer is 1.35. So after all that work, the answer is just 1.35. So the key to getting the question right is to understand percent. So 30% is equal to, as a fraction, 30 divided by 100, or 0.3 as a decimal. So you got to understand that, and then you have to just understand how to set up these equations. So a is equal to 0.3b, etc., and you have to realize that d is equal to 50 and just work backwards and you'll get the answer. So there's a lot of important lessons to learn here: percents, decimals, writing equations, and just reasoning your way through questions. So hopefully this all makes sense. This is a good example to help you learn how to really think and just use your reasoning skills to work your way through a question. Okay, question number 5 is to simplify 3x squared minus 12x cubed divided by 9x. So go ahead and simplify this, and then we'll go over how to do it. Pause the video, try it out now. Okay, hopefully you had a chance to try this out. So let's go over how to do this. So whenever you see a question like this is a simplification of polynomials question. Some people call this division with polynomials, but regardless of what you want to call it, the idea here is you want to see if you can find a number that you can divide each number by. You also want to see if you can take a variable out of each of the terms here. So in this case, we see that we've got 3, 12, and 9. So usually the number that you can divide each number by is the smallest number. So in this case, 3, we can divide each of these numbers by 3. And what we also have to see here is that each term has at least one x in it. So we have x squared, x cubed, and we've got an x. So we can divide each term by 3x. So we've got this 3x squared. We can divide this by 3x. We've got 12x cubed. We can divide that by 3x. We've got 9x. We can divide that by 3x. And so what do we get? Well, 3x squared. So 3 divided by 3 just gives us 1. We're going to divide x squared by x. All right, so x squared divided by x just leaves us with 1x. So we now have x. Now, what about our 12x cubed? So we're going to divide 12 by 3 here. So 12 divided by 3 gives us 4. And we've got this x cubed here. So x cubed, we're going to divide that by x. That is just going to leave us with x squared. And so now we've got 9x here. And what about our 9x? We divide 9 by 3. That just gives us 3. And x divided by x, well, the x's are going to cancel out because x divided by x is 1. 3 times 1 is just 3. So the answer here is x minus 4x squared divided by 3. And that's going to be the answer here. All right, and so some of you might be wondering, well, why is x squared divided by x? Why is that x? And what about x cubed? So let's look at an example here. So we've got x cubed, and we want to divide this by x. So why does that give us x squared here? Well, there's an important exponent rule that we want to understand here. Okay, so any number that we don't see an exponent, all right, we just assume that the exponent is 1. So for example, pick a random number, just 7. All right, so we can write that as 7 raised to the first power if we want to. All right, so any number raised to the first power, the answer is just going to be itself here. So we've got x cubed divided by x, and we know that we can think of this x as x raised to the first power. All right, so there's a rule, an exponent rule, or you could call it a power rule, where if the bases are the same, so the base is x in each of these terms here, because we've got our x cubed and we've got our x to the first power, so the bases are the same, so we can subtract our exponents here. All right, so we've got x cubed divided by x to the first. That's the same as x raised to the 3 minus 1 power. So x raised to the 3 minus 1 is the same as x squared. All right, so the same thing applies with that x squared here, right? So we've got x squared divided by x. All right, and so again, we've got x. We can think of this as x raised to the first power. We can write that then as x to the 2 minus 1, which is just going to be x raised to the first power, which is the same as just x. All right, so that's why we end up with x minus 4x squared divided by 3. You could also write that alternatively as x, you could write that as negative 4x squared plus x divided by 3. So if you did this problem and that's what you got, know that both answers are the same exact thing here. But what I'm really looking for is for you just to get this, x minus 4x squared divided by 3 is how you would simplify this question. So question number 6 is to solve the following. We've got 20 times x to the negative 3 times y raised to the negative 2 divided by 4 times x to the negative 4 times y to the negative 3. Pause the video now and solve this question. All right, hopefully you had a chance to try this, so let's go over it. So the first thing that I would do if I had a question like this is, first of all, we see this division sign here. So let's rewrite this, all right, as one part divided by the other. So let's stack them on top of the other. So we've got our 20 times x to the negative 3 times y to the negative 2. So let's stack that on top of our 4 times x to the negative 4, y to the negative 3, because that'll make it easier to see. And so this question here illustrates some really key concepts that are difficult for a lot of students to grasp. So let's see if you can challenge yourself and see if you can follow this question the whole way through here. And so, or maybe you got it right, which we'll find out very shortly. So we've got 4 times x raised to the negative 4 and y to the negative 3. So the first thing that I would do with a question like this, and there's multiple ways to approach it, but first I would just do this 20 divided by 4. All right, let's get that out of the way. So 20 divided by 4 is 5. All right, so now we've got 5 times x to the negative 3 times y to the negative 2 divided by x to the negative 4 and y to the negative 3. Okay. And so let's just pull the 5 out of the picture here. Let's not worry about the 5 right now. Let's just focus on everything inside of the brackets for right now. All right, so let's just zero in on a certain part of this question, and then we're not going to forget that the 5's out here. So we'll have to remember that we have that 5, okay? But for right now, let's just zoom in onto this certain part of the question on what's going on inside of the brackets here. So there's an important exponent rule here to understand here. So any number raised to a negative exponent, so let's say we've got some number, a raised to the negative 3, well, that is equal to 1 over a raised to the positive 3. All right, and this is an important exponent rule to understand. Okay, and so also, if we have, say, for example, let's say that we have any number, let's say a raised to the negative 3, and this is an a, not a 9. So if we have a raised to the, or let's say raised to the positive 3, so if we have a raised to the positive 3, that's the same as 1 divided by a to the negative 3. Okay, so hopefully you've got these two rules here. A raised to the negative 3 is the same as 1 over a raised to the positive 3, and a raised to the positive 3 is the same as 1 divided by a raised to the negative 3. Okay, so hopefully you've got that. And so now what we can do here is we can take this x raised to the negative 4 and y raised to the negative 3, and we can apply these power rules here. All right. So again, we've got a raised to the positive 3, that's equal to 1 divided by a raised to the negative 3. Okay, so let me rewrite this one here, make it a little bit cleaner to understand here. So that's a raised to the positive 3 is equal to 1 over a raised to the negative 3. Okay, so let me clean up house here a little bit. And so hopefully you see where I'm going with this question here. All right, hopefully you already are starting to get that. So what we're going to do is we're essentially going to do kind of a little bit of a switcheroo here. All right, so we're going to take the numbers here. So everything in the bottom, so let's just focus on our numerator, or our denominator. So the bottom number in the fraction, everything in the bottom part here is what we call the denominator. So this x to the negative 4 and y to the negative 3. All right, so we can rewrite this question here. We can take that x raised to the negative 4, and we can make it x raised to the positive 4. All right, and we can take this y raised to the negative 3, and we can rewrite that in our numerator as y raised to the positive 3. Okay, and so now we can do the same thing with our numerator. So in the numerator, we had x raised to the negative 3, so we can rewrite that down in the denominator as x raised to the positive 3. And we have this y raised to the negative 2 in our numerator, so we can rewrite that down in the denominator as y raised to the positive 2. And we can't forget that we still have this 5 here, okay? But I just pulled the 5 outside of the question because I want us to focus just on the exponent rules here for the time being. So now we've got x raised to the positive 4 times y raised to the positive 3, and that's divided by x raised to the positive 3 times y raised to the positive 2. All right, so again, hopefully you see what we did here. In the denominator, we had x raised to the negative 3. We brought that up into the numerator. That becomes x raised to the positive 4. Same with this 3. So we have y raised to the negative 3. We brought that up into our numerator, and that's why we have this y raised to the positive 3. And then we did the reverse with the numerator. So we had it in our numerator, we had this x raised to the negative 3. We put that downstairs in our denominator, and it becomes x raised to the positive 3. And the same with this y to the negative 2. All right, hopefully that makes sense. So hopefully you're good on how we got here so far. So now what I want you to remember is the exponent rule that we were just talking about in the previous question. So when the numbers when your exponents have the same base and you've got division, you can subtract, all right? So our x raised to the 4th divided by x to the positive 3. All right, so this is the same as x raised to the 4 minus 3. All right, 4 minus 3 is just 1, so this would become x raised to the first power, or we can just call it x. Okay, so the x's just become, right, so we pull our 5 over, keep the 5 out here. So the x's, x to the 4 divided by x to the 3, it just becomes x. Now the same thing, we can do that with our y's as well here. So y cubed divided by y squared, well that's the same as y raised to the 3 minus 2. Okay, and so we had our y raised to the 3, divide that by y raised to the 2. That is the same as y raised to the 3 minus 2, which 3 minus 2 is just 1, so that gives us y raised to the first power, or just y. All right, so that leaves us with 5 times x times y. So the final answer here is just 5 times x times y. So again, final answer, 5 times x times y. That's the answer to the question. The width of a rectangular backyard is 10 feet less than its length. If the area of the backyard is 600 square feet, what is the perimeter? So pause the video now, give this one a try, and then we'll go over how to do it. Okay, so hopefully you had a chance to try out this question. Let's go over how to do this. So this question here, there's a couple things in this that should right away get your attention. So the first is the word rectangle. So a rectangle, hopefully you know what a rectangle looks like, but if not, let me draw one here. And so this is what a rectangle looks like. So it's similar to a square. It looks similar to a square, I should say, but okay, question number 3. The width of a rectangular backyard is 10 feet less than its length. If the area of the backyard is 600 square feet, what is the perimeter? Pause the video and try this one out, and we'll go over how to do it. Okay, hopefully you had a chance to try this. let's now go over how to do it. So there's a couple things here that should get your attention right away here. So the first is this word rectangle or rectangular. So the backyard is rectangular. So hopefully you know what a rectangle looks like, but if not, let me draw one here on the board. So we've got a rectangular backyard, all right? And so when you've got a rectangle, all right, this portion of the rectangle is the length, and so I'm going to draw a cursive L here. So this portion is our length, okay? This whole portion right here is the length of the rectangle, all right? And so then the portion here on the side is the width of the rectangle, all right? And so let me show you which lines of the rectangle are equal in length. So the lines that have a single slash are equal in length, and the lines that have this double slash are also equal in length. So again, this side right here that I'm tracing is equal in length to this side that I'm tracing. All right, and so this side here that I'm tracing is equal in length to this side. All right, so the opposite sides of the rectangle are equal in length. So that's some basic information about rectangles that you have to know, but that's important to understand, especially for a question like this. So now we see here that the width is 10 feet less than the length. So we can write an equation from that, right? So we know that the width is equal to what? Well, it's 10 feet less than the length. So the width is equal to the length minus 10. All right, so that's an equation that we can write from this here. So this keyword less than is a keyword in word problems that tells you subtraction. So less than is usually a clue that you're going to be subtracting. So to write an equation here, we then just have to use common sense. Well, the width is 10 feet less than the length. Is a keyword for equals a lot of times when you're writing these equations. So the width is, or it is equal to the length, right, minus 10. It's 10 feet less than the length. So that's the first two things that should pop out at you right away. Also, we see this word area and we see this word perimeter. So when you see words like this, rectangle, area, perimeter, you want to go to your formula sheet that you'll get on your test, all right, because you're probably going to be have to do some kind of calculation with this. So the area of a rectangle is equal to side times side. In other words, the length times the width. All right, so side times side. The length, so the side here, which is our length, and the side, which is our width. So length times width. All right, so we've also got our perimeter. So I'm just going to abbreviate perimeter with P. All right, so the perimeter is equal to 2L plus 2W. Okay, so another way to think of that would be like this. You could also think of the perimeter as L plus L plus W plus W. Okay, and so the perimeter, you're just adding up the lengths of all the sides here. So we've got four sides in a rectangle. We've got a length, a width, and another width here. So that's why the perimeter would be length plus width plus width. But the faster way to do it is to just think of it as 2L plus 2W. All right, but either way, you're going to get the same answer here. So we've got our area and our perimeter. But what we're also told here in the question is that the area of the backyard is 600 feet, all right? So again, when you're writing equations, is usually represents the equals, right? So we know that 600 is equal to our area here, okay? And so before we do even any calculations, we have a lot of information here to go off of. So this is what I kind of want to get you guys in the habit of doing, is before you just jump right into a word problem or to a tricky question, just kind of think, be strategic, and look at the information that you're given, really look at what you want to find, and before you just jump right in and start doing calculations, just kind of think strategically so that way you don't waste your time. Now, you don't want to spend too much time planning and strategizing, but you do want to try to think and spend a little bit of time doing this before you just jump right in, because if you jump right into a question, many times you're going to get it wrong. So what we want to find here is the perimeter, all right? So I'm going to put a question mark here, and the question mark is equal to P. So we want to find our perimeter. So we're going to do some calculations here, and at the end of the question, we want to see if we found the perimeter, all right? And so now we can also write another equation here, right? Because we know that the width is equal to L minus 10 here, and we know that in order to get the perimeter, we've got to find that L. Okay, but the other equation here that we can write is our area, because we know that the area is equal to 600. So we can say that 600 is equal to L times W. So the idea here is that if we can figure out what L is and if we can figure out what W is, then we're going to be able to solve the question here. But before we can do our calculation to find the perimeter, we've got to get what L is and we've got to get what W is. So we have these two equations right here. We've got W equals L minus 10, 600 equals L times W. So what we're going to do here is we're going to take this W and we're going to substitute it into our area equation here for this W. Okay, so we're going to take L minus 10 and we're going to substitute it into our second equation for W. Okay, so let me show you what I mean. So we've got 600 here. 600 is equal to the length. And so our width is equal to L minus 10. So we can then replace that second W with L minus 10. Okay, so we now have 600 is equal to L times L minus 10. All right, so normally we know from our order of operations rules that you'd want to do what's inside the parentheses first, but in this case, we have L minus 10, we don't know what L is, so there's nothing really to do inside the parentheses. But what we can do is take this L and we can distribute it. So in other words, we're going to multiply each term by L here. All right, and so here's what we get. So we get 600 is equal to L times L. So what is L times L? Well, L times L gives us L squared. All right, minus 10L. And so if you've been studying for a little while, you've probably come across quadratic equations or you've seen questions about how to factor quadratic equations here. And so you may recognize that where we're going with this is we are in fact going to end up with a quadratic equation here. So if we subtract 600 from both sides of the equation, we are left with L squared minus 10L minus 600. All right, so you'll see that what we end up with here is L squared minus 10L minus 600. And this is a quadratic equation. So quadratic equations look like this, right? You'll have something like this. You'll have an A squared plus B. You'll have AX squared plus BX plus C. Okay? And so in this case, we've got L squared. So 1 is our A, right? And we don't even write a 1 here out front. We have minus 10L. So our B in this case is our 10, or in this case, minus 10. Then we've got minus 600. So instead of plus C here, we have minus 600. Okay, but whenever you see an equation in this form here, in this A times X squared plus B times X plus C, you can solve it using either the solution of the quadratic equation, which I'm not going to show in this video, or you can use factoring. All right, and so factoring is kind of a pain until you get the hang of it, but it's really not that hard. It's just that it can take a little bit of guess and check here. So to do factoring here, this is the approach I recommend here. So we're going to take the coefficient of the first term here. So the coefficient, like I said, is just 1. So we see L squared. We just assume that there's a 1 out front. So it's 1 times L squared, but we don't usually even write the 1, but I'm just going to write it here for the sake of the example. So we're going to take the coefficient here, all right, and we're going to multiply it by negative 600, okay? So 1 times negative 600 just gives us, you guessed it, negative 600 here. All right, so what we want to do is we want to find two numbers that will multiply together to give us negative 600, but they have to add together to give us this middle term here, negative 10. So again, we want to find two numbers that multiply together to give us negative 600, but that add together to give us negative 10. So a good way to do this is just to brainstorm, think of numbers that will multiply together to give us negative 600. And then once we do that, we can see if they add up to be negative 10. So let's just think of pairs of numbers here that will multiply together to give us negative 600. So one pair could be 10 and negative 60. All right, 10 times negative 60 gives us 600. So you could reverse this and you could do negative 10 and 60. Negative 10 times 60 will give us negative 600 as well. But the problem here is that 10 plus negative 60 or negative 10 plus 60, these are not going to add together to give us negative 10. All right, so there's one more pair. There's another pair here that I want us to see, which is 20 and 30. Okay, so 20 and 30 here, but particularly we want to look at negative 20 and 30, or we can look at negative 30 and 20 here. So negative 20 and 30 will give us negative 600, all right, but we also can't forget to check negative 30 and 20. Okay, so negative 20 times 30 will give us 600, but negative 20 plus 30, all right, that's the same as doing 30 minus 20, which is positive 10, so that's not what we want here. But if we look at negative 30 and 20, all right, what's negative 30 plus 20? Or you can think of it as 20 minus 30. Okay, either way, you're going to get negative 10 here. So negative 30 and 20 multiply together to give us negative 600, but they add up together to give us negative 10. So this is our golden ticket here. So this negative 30 and 20, these are the golden ticket here to getting this question correct here. Okay, so we're going to take this equation, L squared minus 10L minus 600. Okay, and we can now reduce it down. And so in order to do that, let me clear some of this work out of the way here. And so I will put this back up here near the end of the question. So if you want to get that later, don't worry about it. You don't have to write that down now. So what we're going to do now is we can now write this as x minus 30 and x plus 20. Okay, so again, what we're doing here is we're factoring the quadratic equation. So what we did was we saw that we have this L squared minus 10L minus 600, and we knew that we had to find two numbers that multiplied together to give us negative 600, but added together to give us negative 10. We found negative 30 and 20 here. All right, and so now we have this minus 30 and we have positive 20. So we write this as x minus 30 and x plus 20. And so we want to solve each of these for x. All right, so we set them equal to 0, in other words. So we have x minus 30 equals 0. So to solve this for x, we want to get x by itself here. So we have x minus 30. So the way that we undo minus is with plus, obviously. And whenever you do to one side, you always have to do that to the other. So this will give us x is equal to positive 30. Now, if we have x plus 20, if we set that equal to 0, we're going to get negative 20. All right, and so we would do this the same way, right? So if we have x plus 20 is equal to 0, the way that we would get x by itself is we would do the opposite, right? So we have plus 20, so we need to do minus 20. Whatever you do to one side, you also do to the other, so we would get x equals negative 20. All right, so the solutions to this quadratic equation are x equals 30 and x equals negative 20. All right, and so, or really it wasn't x, this should be L, all right? So just imagine that all of these x's are L's here, all right? So I changed the x's to L's, but it's the same exact idea applies here, all right? So instead of x's, just think of these as L's here. Okay, so there's nothing really confusing about this. Instead of writing L's, I just wrote x's, all right? So hopefully we're all clear, we're on the same page here that all of these, instead, everywhere that I wrote an x, okay, just think of that as an L, all right? But the same idea would apply either way here. But so the solutions to this quadratic equation are L equals 30 and L equals negative 20. Now these could have been x's. They could have been x squared minus 10x. Okay, it doesn't really matter. The point is that, you know, we have these variables here. So a variable is just another word for unknown. In this case, we just chose to make L the unknown here, and I did that because we're trying to find the length and the width. So L, length starts with L, so that's why I did that. Okay, but anyway, the solutions are L equals 30 and L equals negative 20. So we're not going to have a negative length here, right? So the number that we're really interested in is 30. So we did all that work to find L. So L is equal to 30. Okay, so if you had trouble following how I did that factoring and how I solved that quadratic equation, you can pause the video, you can think about it, you can rewind it, or let me know down below if you have questions. But we did all of this work and we now found that L is equal to 30. So we've got our L here, okay? And so now that we have L, we can get our W, because remember, W is equal to L minus 10. All right, so how do we get our W? Well, we just take this L and we just replace it with 30. So we're going to substitute 30 into the equation for L. So, okay, so W equals L minus 10. We know that L is 30, so we now have 30 minus 10, and we get that this is 20. All right, so we now have our width and we have our length. Okay, so we've got our length. So L equals 30, width is equal to 20. All right, and now we can finally do our calculation. So remember, the whole point here was to find the perimeter. And so the formula for the perimeter, again, is 2L plus 2W. And we now know what L and W are. So we're going to take this 30 and we're going to substitute it in here for L. We're going to take this 20 and substitute it in here for W. All right, so let's do that. So we have the perimeter is equal to 2 times 30 plus 2 times 20. Okay, so if we do 2 times 30, we get 60. All right, and if we do 2 times 20, we get 40. And 60 plus 40 is 100. So the answer here is 100. So we found that the perimeter is equal to 100 here. Okay, and so we did all this work just to find that the perimeter was equal to 100. All right, so now let's recap how we did this here. All right, so the recap again, so we knew that we had to make this equation, W equals L minus 10 here. So that equation just came right from the fact that it says the width of the rectangle is 10 feet less than its length. We also knew that the area was equal to 600, and we know that the formula for the area of the rectangle is L times W. So for any rectangle, the formula for the area is just the length times the width. So we made these two equations. We have our width is equal to L minus 10, and we have that the area is equal to L times W, and we plugged in 600 here. So then what we did was we took the W here, since we knew that W is equal to L minus 10, and we plugged this L minus 10 into our second equation here, the area equation for W. So that's how we got 600 equals L times L minus 10. And so we then did some math and we got a quadratic equation. Then we solved that quadratic equation by factoring. We got our two solutions for the length. So we found that the length was 30 and negative 20, but we're not concerned with negative. We're not going to have a negative length here. So the length was 30. And so then what we did was we used that length to do this calculation for the width. We did 30 minus 10. So we then had our length and our width. And finally, we could solve for the perimeter. And the answer was 100.